Hi friends, thank you for watching. Today we're going to learn how to do the elimination method on systems. Before I show you how to solve the system, I want to show you what we are solving for. So with a system, there are three types of solutions. The first solution is that with intersecting lines. So this is just an imaginary system. A system is two lines or more on one graph. The first type of solution is an intersecting point. So the solution is where those two lines cross, intersecting lines. So just like we see one point, this system has one solution. The second type of solution is parallel lines. That is when two lines never cross. And just like we cannot make a point anywhere, because there is no intersection, the lines do not touch, there are zero solutions. The third type of solution is coinciding lines. Coinciding lines. On a test or on a digital platform, you'll probably see it as a thick line. But in this case, I'm going to just overlap to the best of my ability with this purple line to show you that it's two lines on top of each other. Now, this is like saying there is a point at every point along this line. So a coinciding line has infinite solutions. It is saying from negative infinity to positive infinity, there is a solution at every single point. Okay, so let's go ahead and solve our current system. And we'll see if it is an intersecting line, a parallel line, or a coinciding line. So elimination, it means to get rid of one. In math, no matter if you're going through pre-algebra all the way up to calculus 3, you can only solve for one variable at a time. So it doesn't matter if you solve for x or you solve for y, as long as you are consistent across the entire equation. I'm going to start with x just because it's the first variable listed. I have negative 2x. To get rid of negative 2, I need to add 2. So that means I need to turn this 1x into a positive 2x. That way, negative 2 and positive 2 can cancel each other out. So I'm going to multiply this entire equation by 2. So that I don't confuse myself, I'm going to label this system the original equation or system, and I'm going to list this one as the new system. So I have negative 2x plus 4y equals negative 6. And I'm going to use the distributive property to distribute that 2. When you are distributing, you are multiplying 2 times 1x, which gives me a positive 2x, 2 times 1y, which gives me a positive 2y, and 2 times negative 3, which gives me a negative 6. Now I can eliminate my x's. Negative 2 plus 2x is 0x. I'm not going to write it because at this point we know if something is 0, it can just go away. So 4y plus 2y gives me 6y. Negative 6 plus negative 6 is negative 12. Lastly, we're going to divide both sides by 6. We're left with y is equal to negative 2. So what does this look like in terms of our graph? A point has an x-coordinate and a y-coordinate. We just solved and found out that our y-coordinate is now -2. We're going to solve for our x. Now let's rewind a little bit. You see this red writing? That means that I did something with this equation. I can't then go back and substitute -2 into this equation. It is one and done. Think of it like eating an apple. You can't go back and reverse and eat the apple again. You ate it, you throw it away, hopefully. So now I can only use the first equation. So I'm going to do -2x plus 4 times -2 equals -6. -2 times 4 is -8. And everything I have not used comes down to the next step. I then need to add 8 on both sides. I'm left with -2x equals 2. Lastly, I need to divide -2 on both sides. So I'm left with x is equal to -1. So my solution for my x-coordinate is -1. And my complete answer is the coordinate of -1, comma, -2. If you need help on solving multi-step equations, I also have a video for that. If you know somebody that this video will help, please send it to them. And don't forget to like and subscribe.